Hello children, welcome to another video on Math Olympiad Geometry. Today we will be discussing a very interesting concept relating a square and a rectangle. This might sound a little bit silly in the beginning, but I promise you that you will learn a lot. There is also a related quiz to this particular video. Check the link in the description for the quiz problem. Let's get started. The question is like this: what is the difference between square and a rectangle? Suppose you have a rope which is 40 meters long, a rope that is 40 meters long, and I tell you to create a rectangle with this rope. So, for example, you could make it like this. This is a perfectly good rectangle. Maybe this side is 16, then this is also 16, this is 4, this is 4, total 40, right? So that's a perfectly good rectangle. But then I tell you that make sure that you enclose as much area as you can. So let me write that. Keep the rectangle shape the same, but enclose the largest possible area. How can you do it? Well, notice that if this is 16 and this is 4, the area is 64. No problem. But you can actually change this very quickly. Let's say you make this 14. So let's say one of the sides is 14. So this is 14, this is 14. So that's 28, and this is 6 and 6. In this case, the area is 6 times 14, which is 84. So you see, the area jumped when you change the side lengths. So it's clear that you can make many rectangles with the same perimeter of 40, but their areas will be different. The question is, how can you maximize the area? So let's try this with math. Let's take a random rectangle. Suppose this is x, then this is also x, then this is 20 minus x, and this is 20 minus x, right? Because then the total thing is 40. So what is the area? The area is x times 20 minus x. And we want to maximize this area. So let's try to do that. So x times 20 minus x, if I expand it, I will get 20x minus x squared, which is equal to, now I'll make a little bit of algebraic manipulation. I'll write this 20x as 2 times 10 times x, and this is as x squared. Now I will add a 10 square and subtract a 10 square from the entire thing. You will see in a minute why I'm doing this. And I will, from this is 100, 10 square is 100, minus, I'll have 10 square minus 2 times 10 times x plus x squared. So see, this is the formula of a minus b whole square, right? So what we get here is 100 minus 10 minus x whole square. 100 minus 10 minus x whole square. This is the area of this is the area, right? This is the area that is enclosed by the rectangle. We want to maximize this area. Now see, this is 100 minus something. So the maximum area that we can get to is 100, right? The maximum area that we can get to is 100. And from 100, we are deducting 10 minus x whole square. This is always a positive number because it's a perfect square. Square quantities are always positive, at least non-negative. So to maximize the area, we have to minimize what we are deducting. So minimize this. Maximize the area. To do that, we minimize what we are subtracting. And how do we minimize it? Well, we can, the best thing we can do is just make sure 10 minus x whole square is 0. If it's 0, then 10 is equal to x. Which means this is a square. Has to be a square. If x is 10, then this is 20 minus x, which is also 10. This is 10 and this is 10, and the area is 100. So among all the rectangles with perimeter 40, the one with the highest area is the square. That's the relationship between the square and the rectangle. So if you are increasing the area of the rectangle, visually think about it. You are increasing the area of the rectangle. To do that, the length and the width are actually coming closer to each other in length, and the rectangle is turning out to be a square. There's a nice little visualization of this thing. Thank you for watching. Check the link in the description for the quiz. And also, if you're interested in outstanding programs in mathematics, physics, computer science, ISI-CMI Entrances or research projects, check the link in the description for more detail. You will find something interesting. Take care and bye. I'll see you in the next one.